So let's take a look at finding the volume of objects using the disk method. So the formula for the disk method is the volume going to be equal to pi times the integral from a to b of r of x squared dx. And r of x is just the radius of the solid object, which ends up being the function. And notice that everything in terms of x, if you're rotating the region around the x-axis, but if you're doing it around the y-axis, then the only thing you need to change is the variable. So instead of r of x, we have r of y squared dy. So for problem number 1, we have to find the volume of the region bounded by y equals 7 minus x squared. So y equals 7 minus x squared. X equals negative 2. X equals 2. And the x-axis rotated about the x-axis. So I'm just going to draw a rough sketch here of the graph. So we have the xy plane here. We have y equals 7 minus x squared. So basically we go up 7. And then it's kind of like a downwards x squared graph. So something like this. And then we have x equals 2 or negative 2 and x equals 2. So something like this. And the x-axis. So I'm just going to shade in the region that is being bounded by those graphs. And it's telling us to rotate the object or the shaded region about the x-axis. So we need to rotate around this axis. So once again, I'm going to write the formula for the disk method. The volume equals pi times the integral from a to b of r of x squared dx. And since we are rotating everything about the x-axis, we're going to put everything in terms of x. So if I were to plug in, we already know what our a and b bounds are, because our x bounds we're going from are negative 2 to 2. As shown in the graph, we're going from negative 2 to 2. So put pi times the integral from negative 2 to 2 of r of x squared. Now we just need to find what r of x squared is, or we need to find first what r of x is. So in order to find the radius, I'm just going to draw a close-up of the graph. So just the shaded region. And if we're trying to find the radius of the function, and the x-axis is the axis of rotation, we're basically going to go from the axis of rotation all the way to the outer function. That will be our radius. And the radius is obviously this outer function, which is y equals 7 minus x squared. So if I were to plug that into the formula, we get the volume equals pi times the integral from negative 2 to 2, which are our two bounds, of r of x, which is equal to 7 minus x squared. And remember, r of x is squared, so we have to put 7 minus x squared, that entire function squared, dx. Now I won't antiderive this by hand, but this will be what you plug into your calculator to get to the final answer. And I just plugged into my calculator and I got around, well, to be exact, I got 2012 pi over 15 units cubed as the exact answer. So for problem number 2, we have to find the volume of the region bounded by y equals the square root of x, y equals 3, and the y-axis rotated about the y-axis. So notice how it says we have to rotate the region around the y-axis, which means that we must put everything in terms of y. So if I were to draw a sketch of the region, we have y equals the square root of x, so something like this, y equals 3, and then the y-axis itself. So we got this shaded region here, and we're basically trying to rotate this shaded region around the y-axis. And so if I were to draw a better representation of what the region will look like, rotate about the y-axis, we'll get some kind of upside down cone. So it looks something like that. So now I can begin to write the formula. So the volume is going to be equal to pi times the integral from a to b of the radius, and this time we're rotating around the y-axis, so everything needs to be in terms of y. So we have r of y squared dy, and since we're putting everything in terms of y, we have to put y bounds as well. So our a and b is going to be from what y values is the region going from. And we know that it starts at 0, right here it starts at 0, and it goes up to the line y equals 3, which means that we're going from 0 to 3 as the y values. So we get pi times the integral from 0 to 3 of r of y squared. And in order to find the radius, it's just going to be the function. So the axis of rotation is the y-axis, since we're rotating around the y-axis. So we start from the axis of rotation and go out to the function, and that will be our radius. And the function we're going out to is y equals the square root of x. This is the line of y equals the square root of x. And so if I were to rewrite or replace r of y, we get pi times the integral from 0 to 3 of, and remember we have y equals square root of x in terms of x, but since we're rotating around the y-axis, we need to put it in terms of y. So in order to get rid of the radical, we can just square it, and so x is going to be equal to y squared. So I'll replace r of y with y squared. So now I'll get pi times the integral from 0 to 3 of y squared squared, because we take the radius squared, dy. So then we get the volume is equal to pi times the integral from 0 to 3 of y to the 4th dy. And once again, I'm not going to antiderive this by hand, but this will be what you can plug into the calculator. And when you plug this in your calculator, you should get the exact answer of 243 pi over 5 units.